Hello and greetings. This is Dr. VC Sontake and I am the course faculty for the course Energy Conversion 3. In this video, I am going to discuss about the atmospheric jet engines. They are also called as air breathing engines. So objective of this video lecture is to explain construction and working principle of Ramjet and Scramjet engines. Ramjet engine. Ramjet engine was invented by a French engineer named René Lorin in 1913. It is also called as athodite, Lorin tube or flying stovepipe. Athodite is the acronym of aerothermal duct, aerothermal dynamic duct. Ramjet is a steady combustion or continuous flow engine where the air is continuously flowing into the engine and combustion takes place continuously, and hence we get continuous thrust to propel the engine. So let us first discuss the construction of the ramjet engine. Construction of ramjet engine is shown in the figure. It consists of different components. The very first and vital component of the ramjet engine is diffuser. The function of the diffuser is to slow down the atmospheric air, that is to convert its kinetic energy into pressure energy. In case of ramjet engine, diffuser is having two parts, or I can say two zones. The first one is inlet and supersonic diffuser, where the atmospheric air enters at supersonic velocity, and later part of the diffuser is called as subsonic diffuser, where the velocity of the atmospheric air is reduced to subsonic velocity. Then next component is fuel injection, which injects the fuel into the combustion chamber. Then flame holder, combustion chamber, and finally the convergent divergent nozzle. It is also called as exhaust or propelling nozzle. And the processes are taking place from 1 to 2 in diffuser, 2 to 3 in combustion chamber, and 3 to 4 in exhaust nozzle. So let us discuss the working of ramjet engine. The different processes taking place in the working of ramjet engine are shown in figure 1 on temperature entropy diagram, and also in figure 2 in the different components of ramjet engine. So sequence of operation of the ramjet engine is as follows. The very first process is air intake and ram compression. Process 1 to 2. It is represented on temperature entropy plot by a vertical line, because ideally it is considered as isentropic process, and this process takes place in the diffuser in the supersonic zone and subsonic zone from 1 to 2. The function of the supersonic and subsonic diffuser is to convert kinetic energy of the atmospheric air into pressure energy, called as ram pressure of atmospheric air, called as ram pressure. Then atmospheric air enters into the engine, where its velocity is reduced and static pressure is increased by supersonic diffuser. So this process takes place in the first part of this diffuser. Later, the air further enters into the subsonic diffuser, where it is compressed further and pressure is increased, and this takes place in this part of the diffuser. So from process 1 to 2, ultimately kinetic energy of the incoming atmospheric air is reduced and converted into pressure energy to rise its pressure. So This entire process is represented on TS diagram by process 1 to 2. So in case of ramjet engine, diffuser is the only component which is used to increase the pressure from atmospheric to the required pressure level. There is no compressor or any other device. Then combustion process 2 to 3. It is represented on temperature entropy diagram by a curved line, and it takes place in the combustion chamber from 2 to 3. And this process is generally considered as isobaric process. The air then flows into the combustion chamber where fuel injectors and burners are located. Here it is heated to a high temperature in the range of 1500 to 2000 degrees Celsius by the continuous combustion of fuel. So at constant pressure, its temperature is raised from T2 to T3. And the last process is expansion process 3 to 4. It is represented on TS diagram by a vertical line because ideally it is also considered as isentropic process, and it takes place in the nozzle from 3 to 4. Finally, the highly heated gases are then allowed to expand in a propelling nozzle to the ambient pressure and are discharged from the engine as jet at a very high velocity. So this produces thrust on the engine to propel it in the forward direction. So this way, all the three processes takes place in a ramjet engine, right from compression of the air to the combustion to produce gases, high pressure, high temperature gases, and finally expanded into nozzle to get high velocity jet to produce the required thrust. Now let us discuss some salient points about the ramjet engine. The cycle pressure ratio of a jet engine depends upon its flight velocity. The higher the flight velocity, the larger the ram pressure and consequently larger the thrust. So therefore, a ramjet having fixed geometry is designed for a specific flight Mach number and altitude. These two parameters are called as design point for the ramjet. So if a ramjet is operated at design point, it gives its optimum performance. That is optimum flight Mach number and optimum altitude. Ramjet has no compressor, hence the entire compression depends upon the ram compression taking place in the diffuser. Under static conditions, there will be no pressure rise in the diffuser as no air is entering into the diffuser. Hence, it is not self-operating at zero flight velocity. So, ramjet is not a self-propelling unit. To initiate its operation, the body propelled by the ramjet engine must either be launched from an airplane in flight or be given an initial velocity by some auxiliary means such as launching rocket. So it has to be initially launched from some moving object to initiate the different processes taking place in the ramjet engine. Because the ramjet engine is air burning engine, its maximum altitude is also limited. Because more is the altitude, air density will get reduced and the efficiency of the ramjet engine will also decrease so as its thrust producing capacity. Its best performance capability lie in supersonic speed range of Mach number 2 to Mach number 4. The upper speed being limited by the problem of cooling of the outer skin of the engine body at the high flight Mach numbers. When ramjet engines are actually operated at high Mach numbers, there because of atmospheric pressure, their skin temperature is increased tremendously, and it may damage the ramjet engine. So the high flight Mach numbers will depend upon the type of cooling provided in the ramjet engine. The ramjet engine has no turbine. The temperature of the gases of the combustion is not limited to a relatively low value as in the turbojet engine. Since turbine is the device where high pressure and high temperature gases are expanded, and because of limitation of the turbine blade materials, we cannot make the high temperature gases to expand in the turbine to a higher value. But in case of ramjet engine, there is no turbine, so there is no such limitations of high temperatures of the gases. So that is why a ramjet engine can be made to operate with high temperature gases. The air fuel ratio is 15:1 and the exhaust temperature ranges from 1800 degrees Celsius to 2100 degrees Celsius, which is very high as compared to the jet engine or turbofan engine. And the jet action gives the necessary forward thrust to the engine. The application of ramjet engines are in supersonic missiles and in bombs. Characteristics of ramjet engine. Ramjet engine is simple in construction and should be adaptable to mass production at relatively low cost. No moving parts and hence free from and unbalancing forces. Greater thrust per unit engine weight than any other propulsion engine at supersonic speed except rocket. Thrust to weight ratio is very high as compared to the other types of jet engines. Its fuel consumption is too large for its application to the propulsion of aircraft and missiles at low and moderate speed. Its fuel consumption decreases with light speed and approaches reasonable values when flight Mach number is between 2 and 4, and therefore it is suitable for propelling supersonic missiles. It is independent of fuel technology and wide range of liquid and possibly solid fuels can be used in the ramjet engine. It appears to be suited to the application in nuclear propulsion. The thrust per unit frontal area increases both with the efficiency and the airflow through the engine. Therefore, much greater thrust per unit area is obtainable at high supersonic speeds. The best performance of ramjet engine is obtained at flight speed of 1700 km per hour to 2200 km per hour. An application is in supersonic missile and bombs. The next one is scramjet engine. Now, working principle of ramjet and scramjet engine is almost similar. Ramjet and scramjet engines are also similar in construction, but with the only difference that in scramjet engine, the air is entering into the engine with supersonic speed only. There is no subsonic speed or subsonic zone in the diffuser of scramjet engine. So construction of scramjet engine is as shown in figure. It also consists of diffuser, and this diffusers allows the air to flow at supersonic speed. Then fuel injection, combustion chamber and nozzle, similar to ramjet engine. Now a scramjet, also called as supersonic combustion ramjet, is a ramjet engine in which the airflow through the engine remains supersonic or greater than the speed of sound. A scramjet engine is an improvement over the ramjet engine as it efficiently operates at hypersonic speed and allows supersonic combustion. Thus, it is known as supersonic combustion ramjet or scramjet. Scramjet powered vehicles are envisioned to operate at a speed up to at least Mach number 15. When the scramjet engine was first designed, it was anticipated that the scramjet engine would operate at a Mach number of 15. A dual mode ramjet, in short it is called as DMRJ, is a type of jet engine where a ramjet transforms into scramjet over Mach number 4 to 8 range, which means it can efficiently operate both in subsonic and supersonic combustor modes. So that is the dual mode ramjet engine. It can operate like a ramjet as well as like a scramjet. However, ground tests of scramjet combustors have shown this potential, but no flight tests have surpassed the Mach number of 9.6 attained by the NASA's scramjet engine named as X-43A flight. Its reference is given in the bottom. What does it mean? Though scramjet engine, when designed initially, was expected to achieve the Mach number of 15, but so far uh, whatever the scramjet engines are designed and tested, the highest number of speed attained by any scramjet engine is of Mach 9.6, and that is by NASA's flight X-43A. And Indian version of scramjet engine is also under development. An important development in ISRO's Air Breathing Propulsion Project (ABPP) occurred on August 28, 2016, which was the successful flight testing of its scramjet. Its reference is given in 2. The August 28 test was the maiden short-duration experimental test of ISRO's scramjet engine with a hypersonic flight at Mach 16. The scramjet engine, designed and tested by ISRO, could achieve the Mach speed of Mach 6, and still it is in the development stage. So learning outcomes of this video: at the end of the lecture, learner will be able to explain the construction and working of ramjet and scramjet engine, and will also able to distinguish between two types of jet engines. In the next lecture, I am going to discuss or explain the construction and working of pulse jet engine. So with this, I come to an end of this video lecture. Thank you for passionate listening and your kind attention. Happy learning.